Here comes the last lesson of the chapter 2 about quadratics. In this lesson, we'll be looking into modeling with quadratics. So what's modeling? Well, first of all, let's understand what's a mathematical model. Okay, we're not walking on a bridge. We're not doing catwalking. So a mathematical model is a mathematical description of a real-life situation. Simply, it means we apply maths in real-world context. For example, the flight path of a moth. If you know how a moth flies, so imagine here's a light source, a fire. Yeah, vroom, fire. And then here's a little moth. The moth doesn't go into the fire straight away. They don't burn themselves straight away, even though they will eventually. Well, that's that story. But they usually just go past, get a bit closer, and then fly, get past, getting closer, and then vroom, and died. Right. The circular property of a running track. So how do you make sure the running track is perfectly, in the track? That's this arc in here is a perfect circle. There's a lot of maths in there. The trajectory of a basketball into loop. So here is Stephen Curry. Not a basketball fan, but here's a loop. I don't know how to draw a loop. That one here. Can you see this is actually a quadratic? A quadratic. So if you play any games like was it 2K24? What's that? What 2K24? What's that? The basketball. The free famous basketball. The famous FIFA equivalent of basketball. Can't remember the name. I don't play basketball. So you can actually use the graphics behind. The maths behind the video games could be a quadratic. Even though I doubt it, they will use probably some more difficult maths for 3D version. But essentially, it's a quadratic. It's a parabola. So the key skills to do well in modeling quite important because modeling is a big part in A-level maths. You'll see a lot of modeling later on in chapters: trigonometry, logarithms, exponential, parametric. There are lots of differentiation. There are lots of modeling in different chapters. So these key skills are important throughout the whole modeling aspects of the specification. So first, knowing which letters are variables, which ones are constants. Not all letters are variables. So what are variables? Variables means they change it over time. In different scenario, the values will change. Constants means they will stay the same throughout the whole question, right? So you also need to learn how to link the given numerical or worded information to the variables. So usually we judge it by the units if we can look at the units. Alright, so example here. A hunter stands on the top of a hill. Here's a hunter, my drawing, love it, and shoots an arrow to the ground level to hunt a fox. Yeah, that's a little fox. The height in meters of the arrow above the ground after t seconds is modeled by this function. Alright, h of t means a function of t, h because height, so t, this one here, so this means it's the function of t. It means t is the variable in here. Alright, 5.2 plus 7.35t minus 4.9t squared, where t is greater equal 0. T of course has to be greater equal 0 because t is time. Alright, so when t is 0 means that's the initial height. Part A. Interpret the meaning of the constant term 5.2 in the model. Now, when would the height equals 5.2? So here's a question. When does h equals 5.2? If you want h to equal to 5.2, that means this has to become 0, this has to become 0. So how can we make these two terms equal 0? That is when t equals 0. Alright, if you struggle to understand, try rewind and listen again. Alright, so essentially it means the height is 5.2 meters. Actually, let me rewrite that. It means 5.2 meters represents the initial height of the arrow above the ground. So the keyword is initial because t is 0. T is 0 means initial. That means originally, that means this arrow here originally is 5.2 meters above the ground. Right? Part B. After how many seconds does the arrow hit the ground? Now, back to the question again. In this question, how many variables are there? How many variables are there? Even Dora the Explorer will be able to answer this question. There are 2 variables in this question, by the way. Sorry, I should have mentioned in the beginning. 2 variables. The first one is t. T represents time. What about the other one? The height. H represent. Okay, so h of t means the height depends on time. So h is still a variable, height. All right. So part B. After how many seconds does the arrow hit the ground? So which variable are they asking for? After how many seconds means part B, they're asking for time. Now, if they're asking for time, then surely we have to know the height. Does that make sense? Right? So, in part B, after how many seconds does the arrow hit the ground? So, means the question needs you to be able to transform this into some information about the height. So, when it hits the ground, what is the height? Now, we start from 5.2 in here. When it hits the ground, in here, the height is 0. That means when it hits the ground, meaning the height is 0. So that's what we meant by we need to be able to link the given word information to variables. So h equals 0. Let me start again, part B. The question asks us about how many seconds. How many seconds means they want to find time. If we want to find time, we must know height. Therefore, whatever information coming out from it must be about the height. Hit the ground, so we need to think about height. If we start from 5.2 in here, when it hits the ground means surely h equals 0, because we start from 5.2, then hits the ground, h is 0. So h is 0, so when h is equal 0, so we can write that when h equals 0, so we can rewrite the equation 0 equals 5.2 plus 7.35t minus 4.9t squared. These are weird numbers, but that's fine. You expect to use a calculator again to solve the quadratic equation. So you can put in a calculator, you should get t equals negative 524 or t equals to 2.02 seconds. You'll of course reject the negative answer because t cannot be negative, so t equals 2.02 seconds. That's the answer. Part C. Write h of t in the form of a minus b bracket t minus c squared. Do you remember what form is this? Yes, completing square form. So we need to be able to complete the square for part C. So let me change the color. Part C. So let me rewrite the question. So h of t equals 5.2 plus 7.35t minus 4.9t squared. We need to complete the square. Okay, it's going to be quite ugly, but here we go. So to complete a square, we want to rearrange the equation to put the t square or the quadratic, the square term in the front. So I'm going to rewrite as minus 4.9t squared plus 7.35t plus 5.2. So I rearranged it. Now, if you don't know what I've done in here, I would suggest you, when you do notes, do write down little steps in here. Okay, what have I done in here? Why do I do that? Okay, so I did that because when I complete a square, I need the t square term in the front. So why? These are the little prompts for you to write your little own notes. When you read again, so you know what I've done. Next, to complete a square, we need to factorize this term out. So I'm going to factorize negative 4.9. So it'll be t squared, a plus becomes a minus, 7.35 divided by 4.9 is 1.5. A really nice number in A-level maths, in terms of A-level maths. The 5.2, we don't have to do anything about that. Completing square has nothing to do with the constant term. Then I need to half that number, so minus 4.9. And then becomes t minus half that number, 0.75 squared, and then subtract this number squared, so 0.75 squared plus 5.2. And then I can do t minus 0.75 squared, just put in the calculator, I get 0.5625 plus 5.2. Just bear it in mind, when we square this number, there's no bracket. Next step, I multiply minus 4.9 back in, so it'll be minus 4.9 bracket t minus 0.75 squared. Minus 4.9 times negative 0.5625 is plus 27 plus 0.5625. Am I right? It doesn't look right to me. Let me double check my answer. Indeed, I was wrong because the number looks way too big to me. I think I put decimal point in the wrong place. It's negative 2.75625. I didn't forget to add my 5.2. Then I will do 2.75625 plus 5.2, which is 7 points. So h equals to negative 4.9 t minus 0.75 squared plus 7.95625. And that's my answer, right? And that's the answer. So let me read the question again. Where a, b, and c are constant to be found. So a minus, let me rewrite the question. So the question was a minus b bracket t minus c squared. T minus c squared. So we need to do some matchings in here. So what we know is a, therefore a is a constant term, 7.95625. B is the value in front of the bracket. There's a minus b, so b is 4.9. C is 0.75. Okay. When they say values to be found, that means you have to write the values out separately. Okay. Part D. Using your answer to part C or otherwise, find the maximum height of the arrow above the ground. Now think about maximum height when you talk about quadratics. What are they asking for? Turning point. Turning point. So part D, turning point. They're asking for turning point. So turning point, or the maximum point, is, if you remember how to extract this, basically is the opposite value for the number in the bracket for x, and for the y value would take it as it is. So which will represent height, which will represent time? That's t, that's height. So therefore the max height equals 7.95625, which occurs when t equals 0.75 seconds. And that's the answer, final answer. And that's the end of chapter 2.